All right, welcome to the first part of the tutorial series for Python maze solving. First thing you want to do, of course, is download Python. So that's just at python.org/downloads. Get your version for your OS. And once you have that downloaded, follow all the instructions for installation, and you will have the language interpreter available on your system. And the other thing you want to do is download an editor of your choice. I'm going to go with Visual Studio Code. It's very popular, it's very powerful, and it's very nice and easy to use. So if you want to follow along with how I'm doing it, I'm going to be using Visual Studio Code, and you can download it at visualstudio.com. And then once you have both of those things set up, if you need any help with that, I'll have some links in the description for how to do that easily. But yeah, once you have that set up, you're going to want to start a new file. Just keep everything blank here. And we're going to go to a folder that is called maze solver, and we're going to just start a new file, calling it maze solver.py is the extension for Python. And then there we go. Here is our blank file, and we're going to start there. So as I said in the previous video, the first thing we're actually going to be looking at is defining the maze in Python using the various sets of data and data types we have available to us in Python. So like I said last time, it's going to be a list of wall or not wall, and to define that, I'm going to first need a variable, or in this case, a constant, but I'll go over the difference really quick. So a variable is something that you can define. It's a piece of memory that changes, can change, and so we can define it by just writing the name of the variable and then equal sign and then the value. So if we wanted to do let's say name is equal to Jesse, and notice there's no semicolon here, and that is good enough on its own. We can print name and it would work. To run it, we can just click run and debug, and then click on this Python file, and we see here that we have, after a little loading here, we have Jesse. There we go. Not only that, but we can have an age for, let's say, 20 right there. So name and age. Let's say for a Boolean, we can say is male equals true. And true in this case, sorry, don't need a semicolon. True in this case is spelled with a capital T and F with a capital F right there. And so with this, we can define some variables, and that's how you do it. But if you wanted to define a constant, which is like a variable, but one that just never changes, we can do so like this. Name, all caps, equals Jesse. And this cannot be changed. The other ones, let's say I wanted to take the age, and I wanted to do equal 21. This will work, and that'll do just fine. And if you print it twice, it'll be 20 the first time and then 21 the second time. But if you try and change name equal to anything else, it doesn't give an error right here, but it will give an error when you try and run it. So with this in mind, we're going to define a maze, and the maze we want is actually going to be constant because we don't want to edit the maze per se. But let's start with an 8x8 maze and see what we can come up with. So we're going to say maze, all caps, because it's a constant. We're not going to change it. And we're going to set it equal to a list, which is just square brackets. And not only that, a list of lists. So let's define that here. We're going to get creative with our spacing here, just so we don't have to, just so we can see it visually and all laid out. You separate the elements with a comma, so we're going to do a list, and then another list, and we said 8x8, so we're going to need to do 8 of these. And a quick way you can do this in VS Code is you can just highlight all these lines, and then hit Shift, Alt, and then down, and it'll duplicate all of them, which is very nice. And so now we have a template for, these are all the rows, and inside we can fill them with columns. So let's make a pretty simple maze here. I'm actually going to not follow any template. I'm just going to kind of wing it. So I'm going to just do that really quick, inserting zeros for spaces and ones for walls. And I'm going to go through this, and then I'll be back when I'm done that. All right, so now that I have them all typed out here, you can see that it's just a bunch of zeros and ones, and there's currently no start or end point defined, but we can do that later. But for now, we can see that there are little paths. If you're imagining the zeros as spaces, we can see maybe if you were starting up here, you can come down, over, down, up. You know, there's lots of different ways you can explore this maze. Again, we haven't defined the start or end point, but there's walls and there's sections to walk around and you know, explore. So with that, we're actually going to, the first step, before we go into actually maze solving or anything like that, we just want a way to print this maze in a more useful and visual way just to the console. So for now, we're going to look at this terminal and we're going to use some print statements to get the maze itself printing to the terminal in a more helpful visual way. So to do that, we're going to use these ASCII squares. So we have a solid square and like a hollowed out square. And these are just ASCII symbols that you can copy paste from the internet or anywhere. And how we're going to do this is we're going to loop through these arrays and we're going to print them off one by one. And if it's a 0, we're going to print the hollow square. And if it's a 1, we're going to print the solid square. So to actually print this out, we're going to use nested for loops. And to write that out, it's going to look like this: for row in maze. And this syntax here is saying for every row that exists in the maze, we're going to do something. So, and the row here is going to equal whatever element we're currently on, the iteration of the loop. So for example, if we did for row in maze, print row, let's just run that real quick. We will see that we print the entire row. And this already is pretty good for the console, but it is basically exactly like we see up here. Row in this case is equal to one list, right? Every row is equal to one list. So that's a one row, and that's another row, and that's why it's printing. So when it prints row, it just prints the whole list with brackets and everything, and the commas and the numbers. That's what it's doing. So for row in maze, it'll do it, and it'll do it 8 times because there's 8 rows. But for row in maze, we want to actually also access the column. So we'll say for call in row. We're saying row instead of maze because we're trying to get the column in the row. And remember, the row is a list in and of itself, and so we want to access the elements of that list, and that's the columns. So for row in maze and for column in row, now we're going to print the column just to see what happens. So when we print this, we can see we have the entire maze broken down into a bunch of individual print statements, which is a start, but it's not exactly what we're looking for. We want to detect if it's a 0 or if it's a 1, and then print the square accordingly. So we're going to build out a string every single time we go into a new row. And by that, I mean we're going to do, let's say, row ASCII is equal to just an empty string for now. So there's nothing in here, no space, nothing. Row ASCII is a variable name, and it's assigned to an empty string. And then this is going to be reinitiated and reset to nothing every single time we have a new row. And after it's been reset to nothing, we're going to go through all the columns in that row, and we're going to row ASCII plus equals. Plus equals just means append something to that string. So for example, Jesse, a space, and then plus equals MCKNZIE. This would append so that it would eventually just become like this. But with that syntax out of the way, we're going to row ASCII plus equals this. We said we wanted just an empty one if it is 0. So if call call is equal to 0, else this. And so let me explain that syntax really quick. Row ASCII is the variable we defined up here. Plus equals, we're adding on to that string. So the first time, let's say it added this, it would just become this because it's empty. And then the next time, let's say it added this twice, it would look like this, and so on, so on. It will build this string as it goes through all the columns. In this case, there's 8 columns. And so as it's going through, oh, that's wrong. Let me fix that real quick. As it's going through, it'll say, hey, I'm going to put this in here if the column is equal to 0. If it's not, I'm going to put in a solid block. And so with this, we're going to every 0 get a hollowed, and every 1 get a solid block. And after we're done doing this operation on the row ASCII, we're just going to want to print row ASCII. So print row ASCII, and let's just see what happens when we run this. There we go. We have a full printout of what the maze could look like with some blocks. That's already huge progress and way ahead of where we were before. Just one final time to go through exactly what I'm doing here. This maze is a constant that has a list of lists of 1s and 0s. And the 0s are representing spaces and the 1s are representing walls. But it's arbitrary. In this case, we haven't used that logic yet, so it doesn't really matter. And then we're going through the maze. We're looping through a row in the maze. And these keywords here, for is representing the loop. In is a special keyword in Python that evaluates to a special logic where it assigns a variable from things in a list or an iterable, because lists aren't the only thing you can use in loops, but it's a keyword that's doing a lot of the work for us. So for row in maze, and every time we go to a new row, it'll assign that to this variable row, which we can access here. And then within this, every time we get a new row, we want to assign a row ASCII, which is a variable we defined, and we want to make it nothing. And then we also want to loop through every column in the row. If the current column row, so the coordinate, so let's say the very first one we do, this is the first row, and this is the first column, it's just a 0. It should add this if the column is equal to 0. And this equal to just means is like an equal operator, and as opposed to this, which is an assignment operator. If it's equal to 0, else give it this this solid block. And I have a little space here after each one just to get the spacing right, otherwise it would look pretty squished. So with all of this out of the way, going through every single one, and by the way, this can be 1, and it will be the exact opposite, it'll reverse it. But this syntax of plus equals, and then an if, and then a column, equals else, this is what's known as a ternary operator, and it's not the most basic syntax in Python. You can write this a different way, and I'm going to show you how to do that next. Another probably more basic way to do this is writing out just a whole if statement in its entirety. So if call is equal to 0, and then a colon there to get into a new row. If call is equal to 0, then row ASCII is plus equals this. Else row ASCII plus equals this. So this is the full form of everything we just wrote. Call being the current number, and evaluating the equality. If it is equal to 0, we have the hollow, and if it is not, we have the solid. And this, as you can see here, will do the exact same thing. There we go. And this print statement is being run for every row. So the first print is going to do this whole row, and then the next print is going to do the next row, and so on and so forth. But yeah, the next thing I'm going to teach you in this video is how to extrapolate all this logic into a function in Python. So I've gone ahead and changed it back to the ternary operator just because that's how my brain understands it, and it's basically English. This, if this is equal to this, else do this. It's just laid out really nicely. But I'm going to show you now how to change this all into a function. And by function, I mean a piece of reusable code, a block of reusable code that you can call over and over again, and you don't have to rewrite every time. So in Python, you say def, the name of the function. So let's say print maze ASCII. It's always good to be very descriptive in your function names. And then we have open and close parentheses to take in arguments, and I'll go over what that means in a bit. And then a colon, and then a new line, and then you can put all this logic here. You can put it right there. And this tabulation is going to get a bit tricky. There we go. So this is now what it looks like, and not much has changed. But you notice now if we run, nothing happens. And that's because we haven't yet called the function. So this is a function definition. That's the DEF. That's what that stands for, definition. So we define the function. We define what the function should do, but we actually haven't yet used it. So let's go ahead and call it and use this function that we just defined. And we call it simply by doing print maze ASCII, or the name of the function, and then open close parentheses. And that's it. That's all it takes to call the function. So now let's try it, run and debug. And there we go. We called the function. And this is great. This is already perfect, because now if we need to, we can run this function multiple times and we can get it all out twice, which is pretty neat to look at least. But more so, it's useful just because we don't want to rewrite the same logic for things that we want to do that only have slight differences. And those slight differences are defined using these arguments, these parameters. So currently, this function has access to this maze because of this keyword right here, maze, capital M-A-Z-E. It's defined up here. So since it's defined up here, this function knows what this is. But let's generalize this. Let's call this a maze, and let's take an argument maze up here. Now, this function isn't referring to this maze at all. It has no idea about its existence. It's not referred to anywhere here. But that's okay, because we're going to pass this maze into this function through these parameters right here. So just M-A-Z-E. This is not going to work because this name doesn't work with this parameter. This is its own parameter to be used within the function. When we're actually giving it a value, we have to give it the value right here. This right now is called maze because it matches this one, but let's say this is maze example 1, because let's say we have multiple examples, then this also needs to be maze example 1, because that's the value we want to pass into this maze. So now let's save it and let's run this and see what happens. There we go. We got the exact same maze printed out, and now we have it extrapolated away into a function. So if we have multiple mazes, we can run this function multiple times and run it with different mazes, and it'll be able to run without having to retype all of this code. So that's it for today's video. Please feel free to ask any questions you have in the comments, or shoot me a message if you know me. And yeah, next video we're going to be talking about other functions that you can make, and we're going to start the very, very basics of beginning some of the logic for how to actually make a maze solver. Specifically, we're going to be laying out how we might get a start and end point, and how we might find if a certain path is even possible to take at all. But with that, I will see you guys in the next one. Cheers.